Hello and welcome to this IONICON webinar. Please sit back and enjoy the upcoming presentation on the brand new VOCentinel. IONICON's VOCentinel provides a novel solution for automated real-time monitoring of atmospheric VOCs with minimal user interaction required. Let's start with the basics. The backbone of the VOCentinel is the PTR-TOF 3000 platform that was developed for industrial-grade robustness and stability, while conserving the highest degree of analytical performance. The VOCentinel leverages recent technological advancements in PTRMS, such as the new ultra-clean ion source INVION. INVION very efficiently produces our reagent ions. Ionic and neutral interferences are effectively removed, resulting in a reagent ion purity up to 99%. Additionally, this ion source enables very fast switching between different selective reagent ions, including H3O+, NO+, and O2+. Reagent ions are injected from the ion source into a drift reactor, and here we ionize our VOCs via soft chemical ionization. We control the collision conditions in the reactor, and thus get a very well-defined ion chemistry. To ensure quick response times, all wetted surfaces are treated with IONICON's Extended Volatility Range, EVR technology. Finally, all the ions are separated by their mass-to-charge ratio and detected in the time-of-flight mass spectrometer. Let's take a closer look at the ion source. As already mentioned, we can cycle very fast through the reagent ions. This slide shows a typical ionization pattern we use in the VOCentinel. Starting with ionization in H3O+ mode, we ramp the electric field strength in the reactor. Then, we switch to O2+ ionization at high field strength, followed by NO+ at low field strength. This complete cycle takes about 1 minute and is then repeated over and over again. This procedure creates unique patterns that allow for quantification and identification of VOCs, illustrated on the right-hand side. Such unique patterns arise from fragmentation ratios at given E/N ratios, as well as compound-specific ionization channels at well-defined reaction conditions. Even though we continuously cycle through the different ionization modes, instrument stability is excellent. The graphs on this slide depict the results of repetitive standard addition of acetone and benzene. This demonstrates that the precision and reproducibility of the quantification is well within the combined uncertainty of the standard addition. Another feature that is implemented in the system is IONICON's new Dynamic Humidity Control, DHC. DHC compensates variations of the sample humidity by the controlled addition of water vapor to the sample flow with virtually no dilution effect. A very prominent ion chemistry example of strong dependence of product ion yields on sample humidity is the proton transfer between hydronium ions and formaldehyde. In this case, the effective sensitivity changes largely between dry and humid samples. Previous approaches to correct for such matrix effects have used calibrations at various humidity levels and parameterized sensitivities. Dynamically controlling the sample humidity tackles this challenge at the root. That means by stabilizing the humidity, we have true humidity-independent detection of VOCs. As a result, the product ion patterns of VOCs are very precisely reproducible. The VOCentinel system is operated by our AME software. AME stands for Automated Measurement and Evaluation. The software automatically gathers the complete chemical information by cycling through the multiple ionization modes. AME measures fully automated with detector tuning, background determination, and transmission correction. Real-time data evaluation is achieved by on-the-fly peak fitting, automated signal averaging, background subtraction, and most importantly, a sophisticated pattern matching algorithm that minimizes chemical interferences. In summary, the necessity of user interventions is absolutely minimized with the VOCentinel. The robust backbone of the PTR-TOF 3000, combined with the direct humidity control, the INVION source for quick switching of SRI modes, and the automated measurement and evaluation software, make the VOCentinel an ideal instrument for trace gas monitoring in various fields such as air quality and environmental monitoring, industrial safety and fence line or property line applications, to name a few. In the following slides, we show an impressive application example where the VOCentinel detects and quantifies a broad range of compounds and intrinsically minimizes chemical interferences. A recent paper showed that isoprene measured in urban environments can have significant interferences from fragmentation of aldehydes. The authors applied trapping and pre-separation of air samples before analyzing them by proton transfer reaction time of flight mass spectrometry and conclude that by assigning the product ion C5H8H+ to isoprene, urban isoprene concentrations may be significantly overestimated. As shown earlier, the VOCentinel gathers a wealth of chemical information. Trained for potential interferences, this additional information allows to distinguish isoprene from such interferences, and the VOCentinel quantifies in real time isoprene and the interfering compounds. Beyond that, the sophisticated pattern matching algorithm is also robust against unknown interferences. The graph on the right-hand side shows the results of a standard addition containing 9 parts per billion by volume of isoprene, which was sequentially spiked with large mixing ratios of oxygenated compounds. While the oxygenated compounds are quantified at levels of 30 to 95 parts per billion and do not show cross-sensitivities amongst each other, the measured isoprene mixing ratio remains at 9 parts per billion, within the combined uncertainty of the standard addition. Now we are taking this trained VOCentinel to analyze the urban atmosphere. The ion signal at mass 69.07, measured at an E/N of 129 Townsend, shows strong variability. The peak fitting and sophisticated pattern matching approach of the VOCentinel reveals that also in this urban environment, the mass 69.07 signal originated largely from oxygenated compounds. The VOCentinel, however, was capable of distinguishing isoprene, and these oxygenated VOCs and quantified isoprene to reach at most a few tens of parts per trillion in a varying mix of hundreds of parts per trillion of oxygenated VOCs, without trapping and pre-separating the sample by means of gas chromatography. In conclusion, the VOCentinel is a robust PTR-MS analyzer for automated air monitoring. It delivers quality-assured data of a wide range of VOCs, from anthropogenic to biogenic sources. Utilizing combined pattern matching and peak fitting at different ionization modes, IONICON's VOCentinel significantly reduces potential interferences. If you want even more information about the VOCentinel, why don't you visit our website at ionicon.com. There, you can find out what the University of Innsbruck is using the VOCentinel for, and technical specifications, as well as a comprehensive product fact sheet are available too. Finally, we would like to thank you very much for your attention and hope that you enjoyed this webinar about the new VOCentinel. If you have any further questions or suggestions, please do not hesitate to contact us at info@ionicon.com. Have a great time and all the best!